Welcome to the Mineral Database application, version 1.1, now featuring 3D crystal structure animations. To begin, tap About and then How to use the database. Here you will see a description of the many parts of this app that are accessed through the button navigation bar. Note that you can easily move from one view to another by clicking the buttons on that bar. To exit this view, tap the top blue bar. At the top of the screen are three different methods used to sort the minerals in this database. The minerals list shows the minerals in alphabetical order. Let's go to the G's and look at the listing for grossular, which is a garnet group mineral sometimes used as a gemstone. If we tap on Dana number, the minerals in this database will be shown in order of their Dana classification number, from 1 to 77 in this database. This system is used by mineralogists to group minerals. Low numbers generally mean simpler structures, and higher numbers are complex ones. Here we'll look at the mineral auricalcite, which has a Dana number of 16A 4.2.1. The third button for Dana classes shows the same 77 groups as above, only now listed in alphabetical order. If we click on the silica tetrahedra framework silicates, we'll see some familiar minerals, including opal. You can move forward or backward in the current list, here it's Dana class, to see mineral species that are related. Tapping the next button takes us to quartz. Tapping the previous button takes us back to the mineral opal. Now, let's give the opal screen a closer look. The I button in the upper left corner gives information about the mineral photo. Tap off the window to close it. The small white dots underneath each photo show that more than one photo may be included. You can either swipe the image to see the next photo, or tap the dots. On the right are photomicrographs of the minerals in thin sections, which are 30-micron thick slices viewed using a polarizing light microscope. Again, the information for the photo can be viewed by tapping the I button. The transmitted light, or reflected light labels, indicate whether the image was photographed using plain polarized light in transmitted or reflected light mode. The XPL button indicates if the image was viewed with crossed polars, a way of manipulating the polarization of light passing through the sample. The other physical properties fields are terms used by mineralogists to describe specific mineral species. Now let's choose another mineral. We'll tap the minerals list, choose S on the index tab, and then the mineral stilbite, which is a species in the zeolite group. Now we will switch to the optical properties and structure view. On the left is the shape of the crystal under ideal conditions. Just drag across the shape to rotate it. Tap once to activate the auto-rotate feature. Tap it again to turn it off. On the right is the crystal structure. In these images, you can rotate each structure by dragging. The stilbite structure is composed of interconnected silica and aluminum tetrahedra that share corners. This structure also has a channel running through it, which you can see more clearly when you rotate your view. Tap once to enlarge the structure. Double tap the structure to reset it to the original position. Next, let's investigate the EDS spectra button. This produces a spectrum for this mineral as if it were analyzed by an energy dispersive X-ray spectrometer, or EDS. Tap outside the spectrum to close that view. Now we'll switch to the classification and occurrence button using the example of stilbite. The top portion of the screen shows you the related mineral species in this group and subgroup. if there are any. You can see the entries for these related species simply by tapping their names. Here, we can look at chabazite and then tap stilbite again to return to it. In the bottom portion of the screen are listings of geologic occurrence, showing the rock types in which this mineral species occurs, and selected localities where it may be found. Also shown are the date when the mineral was first named and the derivation of that species name. Note that each screen shows the mineral formula in the center at the top. Now we move to the search view. These fields are all properties of a species that may prove to be diagnostic in identifications. Some of the fields have an I button next to them to provide more guidance on how to use the search field. There is also a How to Search button to give you more information about the values that you can type into a field. This provides a detailed explanation of how search criteria are combined when doing the database search. So let's do a search. Type the word black in the color field and then tap the search button. Your results will appear in the results list. Notice that the current mineral, stilbite, is highlighted in the search results list because it matches the search criteria. But there are a lot of black minerals, so we might want to add a search term to pare the list down a bit. Let's type red in the streak field. Tap the search button again, and now you have a shorter list, but there are still a lot of minerals. Let's do one more field. Type a 5 in the from box of the Mohs hardness field. This means that your results will include only those minerals that are black and have a red streak and have a hardness of 5 or greater. Tap the search button to get your results. Your list of minerals is now much smaller. Let's choose hematite from the list, which will take us to the physical properties menu for hematite. Hematite has a highly diagnostic red streak, which is the color of the mineral when powdered. To begin a different search, tap the Clear All button. This just clears the fields, not the previous search results. A new search generates a new search results list. Here, we will type specular into the luster field. Tap in the luster field, which describes the quality of light reflected from a mineral's crystal surface. For a reminder of the possible search terms for a field, tap the Info button next to the field. Tap the Search button to get your results. Your list of minerals is now much smaller. Let's choose hematite. You can also search for minerals using the Photo Gallery button. You can scroll down to search the hand sample photos of the minerals. Here, let's choose kyanite. Then we can tap the Photo Gallery button again. You can also tap a letter on the Index tab on the right side. We will tap R and then choose the mineral rosacite. You can also search for minerals using the Micro Gallery button. This shows photos of mineral thin sections. This works exactly like the Photo Gallery. It shows transmitted and reflected light photomicrographs taken with a special polarizing light microscope. Some of the images are in plain polarized light and some with crossed polars. Here we've chosen siderite. In conclusion, we hope this demonstration has been a helpful introduction to this mineral database. For more information about this app and others available from Tasa Graphic Arts, please go to the website at www.tasagraphicarts.com. There you will also find information on the textbook that provides background information on this database, mineralogy and optical mineralogy.